Hi, everyone. We are now recording. Okay. All right. This is interesting, guys. Okay. Let's hurry up. We have to speed this along.
Yes.
Okay. So example 6. If a equals -2, what's the value of each of the following? So we have a squared, -a squared, -a cubed, and parenthesis a, -a cubed. All right. This is really similar to what we did in the past, where we you substitute in. You want to use parentheses. So you're combining what we learned a couple weeks ago and what we learned today. So we're going to do -2 squared. See how I'm putting parentheses? So we're going to get -2 squared. Do you guys see the difference? Put the phone down.
Sorry.
Oh, that was on video. But I said that. Okay, so this is going to be -4. So it's going to be -4. You guys tracking this? How about everyone else out there? So then we get negative, and we're going to put parentheses for this one. See how you put parentheses around where the variable is? So we're going to put in the -2. So it's going to be a -8. So it's going to be +8. And then the last one, I have to make sure I stay on the screen here. Am I on? Yeah, I'm still on. So we're going to get a negative parenthesis, put the -2 in there, cubed. This one's a little tricky. Do you see how I put parentheses where the a is, but we still have the negative? So now I'm going to have a +2 cubed, which is going to be 8. So with the cube ones are giving us 8, and the other ones are giving us 4. All right, so that's the main part of that. Let's do one more because we're running out of time. Here I'm like, we have so much time. All right, but don't worry, this class is recorded. I can just stay here after you leave and just keep going.
Well,
that would be really exciting. Okay, so this one is x squared z cubed y. X equals 2, z equals 3, and y equals -2. This is the same thing as what you've done before, except there's exponents, which make it a lot more complicated. Whoops, you fell down, Samantha. I picked you back up. Okay, so we're going to get parentheses squared, parentheses cubed, parentheses. This is like before, you put parentheses where all the variables are. So you're going to put the 2 in, we're going to put the 3 in, and we're going to put the -2 in. Before you do multiplication, you want to do your exponents. So we're going to get 4 times 27 times -2. I do not have a calculator, but I do have my book. So the answer to that one is, anyone have a calculator, want to do that?
sure.
I got it, -216.
Oh, yes, -216.
Okay, you guys need to get calculators, right? Do you have a calculator, Ted?
Yeah, I
Well,
know.
no. You need real calculators. Real calculators, people.
It's
I know, but still, you shouldn't have your
No,
phone.
I'm
Just get real
sorry. I'm
calculators.
sorry. I forgot. I always keep my calculator in my binder for some reason. This one time. Always.
Okay, lesson 20. Now, lesson 20, you need to use the sheet. I have these all. You guys, hopefully you have these from class. You can just pull these out and use them. We're going to use this. This is kind of fun. As long as it can hear me, I don't have my headphones in. All right, lesson 20, we're going to find volume of a right solid. Now, to find the volume of a right solid, all you do is find the area of the base times the height. These are pretty easy. So the first one is the base of the solid looks like this. What shape is that? Right, so this is 4 centimeters down here, and it's 8 centimeters tall. And the figure looks like a 3-dimensional triangle thing. If I drew it, I'd have to go really fast and it would be awful. So in order to find the volume, you find the area of the base, right? This is the base. So the area of the triangle is 1/2 the base times the height. And so I'm going to do this. So the area of the triangle is going to be 16. The height, it tells us on the paper, is 6 centimeters. So to get the volume of the whole thing, this is going to be centimeters squared. The height is going to be 6 centimeters. So when we multiply 16 times 6, anyone have that right offhand? It's 96. So the answer is going to be 96 centimeters cubed. Anytime you're doing volume, you're going to have cubic units. So it's going to be base times length times width times height. Mm-hmm.
Now, where did the 6 come in?
It says on the paper that the height, this is the shape. That's the shape right
so
there.
you figure out the area first, and then you just
Multiply it by the height. These are not bad at all.
that's not.
Okay, now the next one is the base of a right prism. So let's get our right prism going on here. We have, the base looks like this. It's one of these shapes. You can see how everything kind of builds. We're using what we learned before. This is 6, 4, and 10. And it says that the prism is 8 meters high. 8 meters high. So this is just the base. Here's what it looks like for you following along at home. Yeah, that's the shape that we have the base, and then this is our figure. It's this, I can't point to it with the camera like that. So we're going to find the area of this. Going quickly, we're going to drop our dotted line. Remember this? So it's going to be, we're going to divide this 10. This is going to be 4, and then this would be 6, right? You guys all tracking? I'm on speed mode. 6 times 4 is 24. And then we're going to get this one. This would be 6, and this height would be 6 because it's a rectangle. So it's going to be 6 times 6 divided by 2. It's going to be 18. So this is going to be 24 meters, and this is going to be 18 meters. So the area of the base is going to be 42 meters squared. Then we're going to just take it times 8. And we're going to get, for a final answer for that one, 336 meter cubed. And that's how you find the volume of a solid.
Oh, that's good.
These aren't bad, right? Okay, turn the page.
Oh.
I know. Hey, we still have 10 minutes. I feel pretty good about this now. So this one has the base that looks like this, but this one has the circle thing going on, which makes it way more complicated. These are right angles. This is 6 and 5, and it tells us that the height is, it's how many? 10 kilometers high. So we're just going to find the area of this, take it times 10. So I'm going to just do my dotted line. This one's going to be 30 kilometers squared. And then, do you guys remember the area of a circle?
Area times.
It's pi r squared.
Yeah.
Yep. So it's going to be pi r squared divided by 2 because it's half a circle. So we're going to take 30 plus, it's going to be 9 pi divided by 2 because we're going to square this. That's our r squared. And then we're going to take this answer times 10. So just use your calculator. You're just going to put 30 plus 9 halves times 3.14 times 10. And to save time, I'm just going to look this up. It's just going to be 44.1, it's going to be 441.3 kilometers cubed. Like that. All right? You guys tracking with this? Pretty easy, right?
Mm-hmm.
Yes.
All right, now let's do a right circular cylinder.
This.
This is not bad. It's just
No, it's not bad. It's not as bad as it looks. Look, I can draw a cylinder. I have a few little minor skills. It's not very good. Okay, so this one that says that the cylinder is, it's 11 inches high and it has a radius of 6. So look, we have our circle, radius of 6, 11, somebody's high, 11 inches, yeah. So all we do is we find the area of the base, which is pi r squared. This is going to be pi 6 squared. So it's going to be 36 pi. And then what do we do?
times 11.
Times 11 inches. You put that all in your calculator and it's going to pop out 1,243.44 inches cubed. Make sure you get your units on there. Hopefully you did that on the test. Yep.
I did wait, so I did 6 squared, which is 36.
Mm-hmm.
And then I did that times pi divided by 2, but I did
Oh, you don't divide this one by 2 because it's a whole It's not half a circle.
Oh, that's right.
All right.
I almost did the same thing.
Yeah. Yep. It's only when it's like those the rectangles with the little half circle you divide by 2. Okay, the last one is the easiest one, even though it looks the craziest.
Oh, because it gives you the.
So example 5, Matthew caught right onto this. It's a shape that looks like this. And it tells you that it's 52 feet squared. And then it tells you that the height is 15 feet.
Oh, and you just multiply.
Yeah.
That's so easy.
At first, I was like, oh, it has a curve, so you subtract it.
Yeah, we
by
couldn't find
the
this.
half circle or whatever else it was.
So we're just going to take 15 times 52, and we're going to get 780 feet cubed. And they're always cubed because it's volume. The areas are squared. Okay, we're ready. Let's go on the next lesson. Oh, exponents again. All right. All right. They gave us a little break. They throw the geometry in there, give you like a little break. Maybe it's not a break. I don't know what it's called. So lesson 21 is called Product Rule for Exponents, Addition of Like Terms with Exponents. Here's the thing you have to remember. X to the m times x to the n equals x to the m plus n. So basically what we're saying here is if the bases are the same when we multiply, we add exponents. For example, if I had x squared times x cubed, what do you think it would be?
X to the 5th power.
X to the 5th power.
Yeah, because it's 2 x's plus.
Because if you think
3x.
about it, it's going to be this times this, and then 1, 2, 3. And see how
Yeah.
it's x to the 5th?
Mm-hmm.
But when the exponent gets really big, like x to the 20 and x to the 60, you're not going to be like writing all ththose exponents and then counting them. So the way it works is when you multiply, you're adding your exponents.
Oh yeah, I remember this.
Because that's
So
kind
you
of like
mul-
how many x's there are, and this is how many x's there are, and together there are 5 x's.
So do you multiply the x's and then add the exponent?
No,
Or
when
do you
the
just add the
just the
add
exponents.
the exponent?
All right. Another way to look at this is if you had 2 to the 3rd times 2 to the 4th, what are you going to get?
2 to the 5th? No, 4 to the
2 to the Adrian.
It's now
Because it's
the tempting
it's
thing.
really
The tempting
No,
thing.
2 to
The tempting thing on problems like this is to say 4 to the 7th. But when the bases are the same, you keep the base.
2 to the 7th.
2 to the 7th is what you're going to get.
So if the bases are different, you would.
If the bases are different, I'm writing everything in this one little spot because that's all where my camera is.
If the bases are different, you just do the.
Like if I had x squared times y cubed, there's nothing you can do. The bases aren't the same, so you can't add your exponents. You just leave it like that. It's
So
done.
that's just the answer?
That's the answer.
Oh.
Mhm. All right, speed. We might not get to the last lesson. I'm pretty sure we're not. X squared, y squared, x to the 3rd, y to the 3rd.
Wait, what problem are we on?
Example 1.
Okay.
Okay, does anyone want to guess what the answer to that is? Chad.
X to the 5th
Mm-hmm.
times y to the 5th.
Yeah, so you're going to add the exponents on the x's, add the exponents on the y's.
Wait, so it would have.
X to the 5th.
So it'd be
isn't it
X to the 7th?
It's x to the 7th.
Because you're adding the 3 and the 2 from the x and the 3 and the 2.
No, we're going to add these guys together, these, right?
Yeah, but on the problem,
The
both-
problem it says 2 and 5, not 2 and 3.
Oh, I can't read. Yeah.
Yeah,
But
it's
the
not
one on the
just
board,
these.
so you know what it is. The one on the
Yes.
board is like this. We'll just stick with this, but it's 7 on your paper. All right, let's try the next one. Example 2, simplify. X squared, y cubed, is that a 3?
Yeah.
M to the 5th, x to the 3rd, y squared. Anyone want to take a guess on this one? Okay.
M to the 5th, x to the 5th, or m to the 5th times x to the 5th times y to the 5th.
Okay, so you started with m to the 5th. Orders that you're going alphabetical, that's great. So we got m to the 5th,
Oh, I didn't mean to go in.
That's fine. x to the 2, and x to the 3rd would be x to the 5th.
Well, these aren't
And then we have y to the 5th. They're not bad, right?
They're not bad.
Mm-mm.
Not
Okay.
bad.
All right, we're not going to do example 4 or 3 because we ran out of time, but I do want to do example 5 because we need to, it's a different kind of problem. So example 5 on the paper says x squared y p to the 5th plus 2xy squared p to the 5th plus 3p to the 5th x squared y minus 7y squared x p to the, can you see that? 5th.
Why?
Okay, now, are we multiplying anymore?
No.
We're adding.
No.
This is where it's all going to get complicated, guys. So what we want to do is look for ones that are alike. Do we have any more x squared y p to the 5th anywhere?
No. Yes.
Okay, so we underline the guys that are alike. He is like him, right? Is there any more x squared y p to the 5th?
No.
No. All right, let's see if we have any other like terms. Here we have an x y squared p to the 5th. Do we have any more of those?
Yes.
This one right here. So I'm going to double underline those. Now, we're going to add the coefficients together. So how many x squared y p to the 5th do we have?
1.
Well, we have one here, one there, and we have one here, right?
Oh, yeah. So 4. No.
So we're going to have 4 what?
X squared yp to the 5th.
Yeah, okay. And then we have these are like terms. So we have negative 5x y squared p to the 5th. Now, did we add our exponents when we did that? No. When do we add our exponents?
Multiply.
When you multiply. So can you see why it's going to get complicated?
Wait.
How did we get the
we
4
just changed the
x
bases,
squared
right?
y pi to the 5th?
Well, we're adding the coefficients. We're adding the 1 to the 3 because they're like terms.
Yeah.
Oh, so
It's kind of like we have 1 apple and 3 apples, so we have 4 apples. We have 2 oranges minus 7 oranges. We have negative 5 oranges. Okay, so I can see we're going to have a little bit of trouble here, so I'll make a video for the next lesson for sure, and then we'll see how we do on this one. Yeah,
Thank
because we
you.
still have another lesson to do, and the last lesson is the easiest one. So, all right, we'll see you guys. We'll see you, anyone that's watching. We'll see you, Samantha, and that's it for this class. I'm talk faster from now on. All right, we'll see you. Send me your test. Oh, you're welcome.
Bye.
Bye-bye.
thank you. Thank you.
Thank you.
Okay. Wow, I can record this class anytime. Algebra 1. What's the date today?
27.
Yeah.
2018. Save.